In the last lesson, we learned all about how the interior angles of a triangle always add up to 180 degrees. We also learned how to classify triangles by whether they are acute, obtuse, or right. Now, in this lesson, we are going to be learning about the relationships between the sides of a triangle, learning about how the triangle is stabilized by the length of its sides. This is Meet Triangles Part 2, and the learning goals for today is master the method of classifying triangles by sides and being able to determine whether a triangle is a special triangle. Explore and master the relationships between the three sides of a triangle, and being able to use the relationship between the three sides of a triangle to solve related problems. Introduction. When classifying triangles, they can be shown this way. Triangles, then split up into three groups, right, acute, and obtuse, as we learned from the last lesson. If triangles are classified according to their sides, how many types can they be divided into? Classifying triangles according to sides. How can we classify triangles in another way by their sides? Can you find out the characteristics of the following triangles? What do you think about these triangles? What is the relationships between their sides? Well, these have unequal sides. They're called scale-lean triangles. And as I say this, I want you to repeat after me. Scale-lean triangles. And if you like, you can quickly jot down this name on your notepad so you know how to spell it. And so you could write scale-lean is equal to unequal sides. Then next we have the isosceles triangle. Two sides are equal. That's called isosceles. Repeat after me. Isosceles. Isosceles have two sides that are equal. And here we have the equilateral triangle, where all sides are equal. Repeat after me. Equilateral. Equilateral. Over here, the parts of an isosceles triangle is a leg, and the leg is the two sides that are equal. The two sides that are equal are both called legs. And this side that's not equal here is called the base. These are base angles, and this is the vertex of an isosceles triangle. So the vertex is where the two legs intersect. The base angles are the angles of the base, and the two sides that are equal are called legs, and the side that is not equal to the other two is called the base. So here's a conclusion. A triangle with sides at all different lengths are called scale-lean triangles. A triangle with two sides with the same length are called isosceles triangles. A triangle with sides at the same length are called equilateral triangles. What is the relationship between equilateral triangles and isosceles triangles? I want you to think about that. So we can classify triangles according to their side situation. Classifying triangles by sides, scale-lean triangles, and isosceles triangles. You might be wondering, well, what about equilateral triangles? Well, there's still more. Equilateral triangles are parts of the category of isosceles triangles, because in isosceles triangles, it just means two or more sides are equal. Two or more sides are equal. So there's one type of isosceles triangle, which are just two sides are equal, and there's a special kind where all sides are equal. And the all sides are equal isosceles triangles are called equilateral triangles. So relationships within a triangle. So here's a boy, and he's at his house, and he's wondering, how do I get to school? Which way is the closest? And there are two paths shown here. This is his neighbor, and this is the school. Well, as we learned many chapters ago, we learned that the straight line segment is always the shortest distance. So this orange line here would be the answer. So here's another triangle that's based on this map shown here. Path 1, start A, to C, then to B. So this is path 1. Let me show this some way. Okay. So you would first go to C. First go to C, and then you go to B. That's path 1. Path 2 is when you would keep following AB until you reach B. Just like that, just like that. Let me ask, which path is shorter, and can you prove it? The solution is path 2 is shorter. The line segment between 2 points is always the shortest. From this you get, so from here, you get AC plus BC, which is path 1, is greater than the straight AB. AB plus BC is greater than the straight AC. AC plus AB is greater than the straight BC. Now, do these make sense? You can think of these as all 3 different paths and compare them. One path right here would be the demonstration we just did, and maybe in this scenario, there's a path 1 and path 2. In here, path 1 would be go to AB, then BC, and that is actually longer than AC. Say, for another scenario, path 1 is AC plus AB, so AC plus AB. But that is always greater than BC. So this is what we get when we follow this very simple demonstration. We get the relationships between all of these sides. So let's discuss. In the same triangle, what is the relationship between the sum of any 2 sides and then a third side? 2. In the same triangle, what is the relationship between the difference of any 2 sides and the third side? And 3. What is the unequal relationship between all 3 sides of a triangle? What conclusions can you get through the hands-on experiments? What are the reasons? So, suppose I draw a triangle. I'm just going to draw a really bad triangle right here. This is a triangle. And this is point A, point B, point C. So this is triangle ABC. Then I take a random 2 sides from this triangle. I'll take AC and CB. And the side left is AB. So I want to find what is the sum of AC and CB to AB. But it would seem obvious that AC plus CB is more than AB. And we can prove that by saying this is the boy's house and this is the school. AB would just be from A directly to B, which is the school. But AC plus CB would be A first started from A to C, then to B. So it is obvious that AC plus CB is greater than B. And as you do this for any of the other combinations of sides, you see that the relationship between sum of any 2 sides and then a third side is always greater than the third side. And in the same triangle, what is the relationship between the difference of any 2 sides and then the third side? The difference. So here's the conclusion. I'll cover everything later. The conclusion is that the sum of the 2 sides of the triangle is greater than the third side. The difference between the 2 sides of the triangle is smaller than the third side. Now, I want you to jot this down. These are 2 statements you have to memorize. The 2 sides of a triangle is always greater than the third side. Remember, this isn't just a carefully picked out two sides. It's random selection. The difference between the two sides of a triangle is always smaller than the third side. Today we learned all about the relationships within a triangle. And the two main points we worked on was classifying triangles by side and the relationships between the sides of a triangle. When we classify triangles by sides, we can split them up into scalene triangles and isosceles triangles. In isosceles triangles, one special type of isosceles triangles are called equilateral triangles, where all three sides are equal. The relationships between the sides of a triangle has two big parts that we have to memorize. The sum of any two sides is greater than the third side, and the difference between any two sides is always less than the third side. The two skills we worked on today was master the method of classifying triangles by sides, and being able to determine whether a triangle is a special triangle. Explore and master the relationships between the three sides of a triangle, and being able to use the relationship between the three sides of a triangle to solve related problems.